Right. Well, happy Monday, Algebra 1. We are on one of the last two sections of notes for this unit. Today we're going to be talking about analyzing data, which is section 12.4. And then we'll probably have a little bit of time that we can start 11 or 12.5. But as you can see, it's quite a bit of notes, so we'll probably only get through about the first page or so before we have to call it quits. So, in section 12.4, this is all about after you've already made your graph. So if you're thinking about this in terms of the project, you've already asked your question. So that's going to be kind of step one, is going to be coming up with whatever question it is you plan to ask. Step two is going to be how you collect your data. Step three is you're going to make a graph. And then we're at step four, which is where you're going to analyze your graph. So you're going to look at kind of what information did you get and kind of how is it useful. So in this first example, the Cancer Council surveyed some random people, asking them approximately how many hours they spent in the sun during the previous summer. The frequency histogram for the responses is given to the right. How many people participated in this study? So keep in mind that down here is where we're looking at the number of hours that they actually spent in the sun. This is the actual frequency. What that means is that there were 2 people that spent 0 hours in the sun. That would mean that a frequency of 3, so what I'm looking at is my frequency here. There were 3 people that spent 10 hours in the sun. There were another 3, 20. There were a couple of them here, both at 2, at 30, and 40, all the way up to 9 people that spent 50 hours in the sun. And then I believe this one kind of in between those is at about 7. So here would be 7 hours in the sun, or 7 people that spent 60 hours in the sun. Here we're back up to 9, and then this one we should be back down to 3. So if we want to know the total number of people that were in there, we'd have to add all these up. So we'd take 3 plus 9 is 12, plus 7 is 19, plus 9 is 28, plus 2 is 30, plus 2 is 32, plus 3 is 35, plus 3 is 38, plus 2 is 40. So it looks like there was a total of 40 people that participated in this survey. So then the next question, how many people spent 60 or more hours in the sun? So in that case, you're looking for 60 or more, which would be this section right here. So you would take 7 plus 9 plus 3. It looks like there was a total of 19 people that spent 60 or more hours in the sun during a given summer. So then C, describe the shape of the distribution. Looking at the distribution, if you wanted to draw in maybe like some curves there, it's pretty clear that it's coming down to the left. So this would be an example of what we've called left skewed data, being that it's being pulled to the left. What would be the best measure of center? Remember, anytime you're dealing with skewed data, the median is the better measure of center. Remember, the mean is only if it's symmetric with no outliers. So if it's symmetric with no outliers, that is the only time that you really use the mean as your better measure of center. All right, so in example 2, below are 3 different data sets. We just have to decide whether it's left skewed, right skewed, uniform, or symmetric. So looking at this first graph of the data, it looks like it's definitely got a tail going to the right. So this would be an example of right skewed. And some of this you'll notice is stuff we've already looked at. We looked at this in section 12.2 with socks. The next one would definitely have to be a left skewed graph then, since it's curving down to the left. Now, here's the part that can get kind of tricky, is when you're looking at your stem and leaf, you kind of have to think about it kind of on its side. Let me see if I can maybe get it to turn for us here. But what you kind of want to think about is, well, it's not going to work for us. But what you would want to kind of look at would be if you were to imagine kind of the stem and leaf plot being turned onto its side to where the numbers at the bottom were like the 1, 2, 3, 4, and 5, and then these are the numbers going up. It would have a pretty symmetric distribution. If you notice, it's really not curving to the left at all. It's not curving to the right at all. I would call this a symmetrical set of data. So then for A here, compare the data sets A and B. I think what it means is this is A and this is B. Which one has the larger median? So keep in mind, median is the middle number. That would probably be somewhere between 13 and 14 on graph A. The middle of the data would probably be somewhere between 15 and 16 for B. So I would say data set B would have a larger median. Okay, so then example 3. The stem and leaf plots below show the amount of cash carried by a random sample of teenage boys and girls. For part A, which gender carried more cash? Well, let's see, the highest for boys was 73, the highest for girls was 54. So I would say the boys in general, it looks like, carried more cash on them. For part B, what is the median amount for the boys? This would be where you could use cross-out method, which is what I'm going to do real fast here. So cross one off at the beginning, one at the end, beginning and end, beginning and end, and so on. And let's see where that puts us. Looks like we're going to be at this number of 2 right here, which, remember, to read it from a stem and leaf plot, you put the number 4 in front, the number 2 after it. Looks like the median amount for boys was $42. Now in C, what is the median amount for girls? So we'll do the same thing for girls. Cross those off. And it looks like for girls, that number is going to be at 6. And so again, remember, use the stem first, then the leaf. So it looks like the median amount for girls is $36. So which stated data is more spread out? Hopefully that's pretty clear to see. For boys, you go from 0 to 7 for the stems. For girls, you go from 1 to 5. If you were to find the range for both, you would take 73 minus 7 is 67 for the boys. For the girls, you would take 54 minus 11, which is 33. So which one is more spread out? Pretty clearly it's the boys that are more spread out. Okay, so that wraps up the notes for 12.4. That should get you as much as you need to be able to get through the homework. I do want to go through a little bit more notes though before you go up and see the sub for the homework for tonight. I want to just go through the basics of linear regression, which is what we'll talk about more on Tuesday. So first thing we need to talk about is a scatter plot. A scatter plot, S-C-A-T-T-E-R-P-L-O-T, consists of an x and y axis and a series of dots. Each dot on your scatter plot represents one new observation from a data set. The position of the dot in the scatter plot represents its x and y values. So basically what a scatter plot looks like, there's a few different examples down here for you, but it's basically just a whole bunch of points on an XY plot. So correlation coefficient is kind of how we measure how closely the points are to each other. So R measures the strength and the direction of a linear relationship between two variables. The values of R always have to be between -1 and +1. The closer the R value is, and really the closer the absolute value of R is to 1, the stronger the correlation. And the closer the dots are, also the stronger the correlation as well. So it basically tells you how close the dots are together. So the different directions you can have, if it's going up and to the right, that would be a positive direction. If it's going down and to the right, a negative direction. And if there really doesn't look like there's any direction, you would just say that there is none. Okay, so as an example here, we've got some different graphs. So you've got some different ways to kind of see it. Notice that a strength of 1 is basically that all the dots would fall on one line. 0.8 would mean that they all kind of fall very closely around that line, and then 0.3 would mean that they fall around the line but maybe not as closely. And so then obviously the same thing over here with these values. Their linear relationship goes from, in this case, weaker to stronger. So in terms of strength, this would be strong, this would be moderate, and this would be weak. And so then in the other direction, this would be weak, this would be moderate, and this would be strong. So then keep in mind on this left side, these are all in a positive direction. Keep in mind on this side, these are all in a negative direction. Okay, so in example 1, and this will be the only example we do today with this, match the graph with the correlation coefficient. So looking at these values, it looks like we should have 2 relationships that are positive and 2 that are negative. So looking at these, the 2 that look like they're positive, this looks like number 2 is positive, and it also looks like number 3 is positive. I would say that number 3 has a much stronger relationship than on number 2, so we would want to pick the value that's closer to 1, which would be A for number 3, and then B for number 2. So then between your 2 negative ones, 1 is definitely a much stronger negative compared to 4, which is a very weak negative. So the stronger negative would be closer to -1, so that would be C. The weaker negative would be closer to 0, so that would be D. All right, that is it for today. Homework for tonight, go ahead and see the sub. Make sure you show the sub your completed notes before they give you the homework. But the homework is going to be worksheet number 12.4, which is going to be on analyzing graphs. Make sure that you work through that. There will be an answer key on Schoology. This is going to be due the next time I see you, so this will be due on Tuesday. That being said, have a good rest of your Monday, everyone, and I will see you when I'm back.